you cannot use, you can, but it's hard to use just regular particles like 1, 2, 3, 4, 5 microns size. Our particles are 17 nanometers. And when you go down to 15 micron line width to 10 micron, how many can you fit inside if you don't use nanoparticles? This is one thing. Second thing, that you want to have electrical conductivity. This is way, way better than what you have today because you need to conduct more current from the panel itself. So what we see right now that with customers that we can improve the efficiency of the panel by 0.5% nominal. And this is something that is very important to the customer. We focus on heterojunction technology in the solar panel. With heterojunction, there is a barrier of how much you can heat the panel. You can go up to 200 degrees in comparison with 700 degrees in the other panels. So our paste works very well under this temperature, and you get better performance.
Wow, it's incredible to learn that. Thank you very much for sharing that. It does spark a few questions over here, but I believe these questions that I have are a little more in the scientific area than the topic we want to cover today, right? So going back into what you mentioned of these sort of like the big market that PV Nano is pretty much addressing, right? Especially with these inkjets, like mainly, of course, you're doing a lot of work on solar cells and solar power, etc. But you're also very big on circuit printing, pretty much with your inkjet. Can you tell us about that, please?
Okay. With circuit printing, we are exposed to many R&D centers around the world, from Japan through Europe to the United States. We see what we work with household names. I mean, in Japan, they printed flat batteries. And the power of conductive ink is that you have the flexibility of digital printing. This is one. Two, if you can run a printer continuously on industrial scale, this is a game changer. This is one of the issues with inkjet. Most of inkjet printers or inks gonna block the printhead very fast.
Okay, like a saturation?
Sometimes saturation, sometimes it's kind of drying, all kind of phenomena.
Okay.
So what we see with PV Nano ink is that it's running smoothly. I mean, no matter how many, right now we're just printing on about 21 printhead in parallel. And if you take ink, the major difference between us and the rest is that the shelf life is about a year versus 3 months to 6 months. You don't need to refrigerate it. It's just room ambient temperature, and also you don't need to shake it. It's all the time the flowing inside the ink. So just put the ink and it starts working. And this is because of the qualities of the nanoparticle. They are kind of very small. The distribution is very narrow and like a triangle, unlike the amorphous other particles that we see on the market.
Right. I mean, oh, sorry, go ahead.
If I want to summarize it, if you look at the 3D printing and the circuit board, mass production scale capability is a must.
Yes.
Without that, it won't work because it's not economical. This is what we bring to this industry. And I believe that more forces will join us when it's come true, because it's complicated there with, let's say, PC board. It's a big logistics, but it's happening. I see it.
Right. Yes. I mean, I'm also very curious then. Now, you've been at PV Nanos for around a year already, right? So I believe you're already going to have a very cool insight into this. And I'm honestly very curious. How does R&D look like then for PV Nano? Because I have to say, the fact that you got to the point where you can create this ink that doesn't saturate and pretty much is so useful and so far ahead of the market, the way you describe it, there has to be some really cool R&D there.
Okay, so what we did in the last year, we even increased our R&D force. We have now 3 PhDs in R&D in
wow.
Chemistries, and one is chemical physics. We have an advisory talent that sits in the UK, and he's one of the top experts in this industry.
Wow.
And we have physicists and application lab and around. So we work with different customers, and we see different, development issues. So We focus in the R&D on our manufacturing process, and the idea there is to stabilize all the time a process. So what we did in the last year, we also expanded for ink to paste. And paste is a different ballgame because the solar
Right.
industry requires paste, not ink. And this is right now. You know, with ink, it's a slow development of the business, of the market.
Yes.
With paste, for the solar, it's here. So you jump into the ocean, right? If you know how to swim, it's a big thing.
Right.
And we work with Tongwei, Longi, all the big names in this industry right now.
Oh, okay. Right. And do you do development for them as well? Like, do you do sort of R&D as a service?
No, we do R&D for ourselves, but to feed their process. We work with two companies that I cannot mention their name right now. They're developing novel technologies that also will change the way the solar market works. And this is a new equipment for the solar market, because in the solar market, the wafer is becoming thinner because you need to reduce cost. If once the wafer was 200 microns, now you want to go sub 100 microns. So you have breakage, so you have non-contact technologies. And this is where we come in and have worked with them with our nanoparticles. So it's a new development for this market, and I believe that it will take on in the next year.
Yeah, I mean, I agree with you that I'm pretty sure she's going to take over within the next year. But I'm just very curious, though, where do you see it going in the following 3 to 5 years? Like, especially in the end consumer part of the solar power industry, right? In the end, purchasing a whole bunch at the moment can be pretty expensive, at least for right now, right? Where do you see it?
Yes. So when you meet a solar panel salesperson, it's all about cost per watt.
Right. Yes. Per kilowatt generation. Right.
Yes. And this is where we help them to reduce the cost per watt. They become cleaner because our ink manufacturing process is very clean. We don't have hazardous material. Everything goes to just regular sewage. So it's very clean. Because if it's additive manufacturing, not subtractive, you also save raw material. So what we do with this industry, we can save up to 50% of the material that is laid on the panel.
Okay.
This efficiency. And this is double gain for the customer. So what we see right now, we're focusing on silver because this is where the industry is at right now. You know that silver is under big constraint in the world as a resource. And the world will go to copper. We have already copper nanoparticles. Some customers are using it. And we now make the process that's going to fit also the solar market.
Okay. And is it very different in terms of the synthesis, in terms of actually developing this nanomaterial? Is it very different from silver to copper?
Yes. The manufacturing process is the same in terms of, but when you sinter or cure copper, its sintering temperature, physically speaking, it's higher than silver. So you need to develop a new sintering technique to allow to work on our target market. And this is where we are at now. And I believe that in about 2-3 years, this is where the market will be at, because copper is about 100 times lower cost than silver, and you have more resources in the world. And this is where the industry is pushing right now.
Right. I was very curious to ask you because, I mean, if it seems so great, I was curious as to why isn't it the standard already? I can already understand that it's because of this sinterization process, right?
We have all kind of issues there, not only us, but everybody. But we believe that in heterojunction, we will solve it, because this is a heterojunction and TOPCon in the solar industry are the two major forces right now.
Right.
And we have heterojunction, and I believe that in about 2 years, we'll have a final product.
Oh, that's amazing. I can't wait to see it. Now, I wanted to ask, now, you as you already mentioned, you're doing a lot of R&D efforts, not only for, developing and continuously improving your already existing, products and devices, but also to work on creating these new groundbreaking materials like the copper nanomaterial for solar cells, etc. Right? How do you keep track both of, or not keep track, but how do you make sure that you don't neglect the part of R&D for these very new products versus keeping, your inkjets and the secrets, for example, and everything that you currently have going on, which is pretty much your sort of main selling points? How do you make sure to not neglect one or the other and make sure you push them both?
Okay, it's a good question. I wouldn't say it's a daily effort because we have R&D program and roadmap.
Right.
Our ink is very much matured. What we do with the ink is more kind of solving application with our R&D capabilities, but we're not developing the ink. The ink is there already and it's working. This is the results of about, I would say, 6 years of development.
Wow.
So it's very stable. You know, for me, to be honest with you, when I was in Germany last week, to see, I think it's first time in this industry that you see a printer with 21 print heads running continuously and printing panels. This is just amazing to see it.
Wow, I don't think I've ever seen panels being printed sort of live. I have seen, for example, panels, at least the typical manufacturing process, right? Which is like the single cell being, coming out of the machine. But not the whole panel is cool.
Most of the panels in the world are about that size, about 200 millimeters by 200.
Small cell, yeah.
The large one, it's a technology for architecture. It's like a facades of buildings. It's architecture. And they're very large, 1.6 meter by 60 centimeter, which is pretty big. This is why this technology will not fit these panels. So we use inkjet.
Right. Now, I do have another question about all this precisely, right? With the inkjet. So back when you were doing this R&D for developing the ink itself, you already mentioned it took around 6 years for PV Nano to come up with it. But now you also faced a different challenge, or at least PV Nano did back in the moment, which was where to print it, right? Now we know that you manufacture your own printers, right? Themselves, sorry, or rather, customize them. But originally, where did you print these devices, or where did you use the ink?
We printed on the customer sites. They have printers, and we have new technologies with our customers that they have their own printers. So these new novel technologies are also struggling to get the yield, like in solar, from 95, 96% to about 99%. This is what the market requires. Wow. So we help them to get the last mile and to make it work. So we work in Israel, we work in Germany, we're gonna work in China right now.
Wow, that's actually very cool. It is honestly exciting.
It's very exciting, yes.
It is honestly very exciting. Now, I wanna ask a little less in the science and in the development side of all this, which is what we've been talking about, and more into the efforts and the point of the work you're doing. Right, in the end, all of the work you're doing is pretty much all based on sustainability, because in the end, although solar panels as a whole are very useful and they are a renewable energy that is very clean compared to carbon and coal and whatever, they're still not 100% eco-friendly because the manufacturing process, especially the most commercial ones right now, use use silica or silicium, etc., and that the manufacturing process is very harmful for the environment. So how do you ensure the sustainability of your products with the nanoparticles you're using, with the ink you're using, with even through R&D? How do you address this topic?
Okay, so we cannot affect the entire industry. We can affect our part of this industry.
Of course.
So our inks, when we develop, we don't need to print them on silica that we throw away all the time. We just print them on sometimes even papers, on glass that we reuse all the time. And our manufacturing process is very clean. So there's a lot of going on in the lab. Once we come to the customer site, we already know what we're doing. And usually there's just a little bit optimization and you're already there. For example, if we need to do printability tests, we print 1,000 solar panels. We don't print 1,000. We print only one, and then we run it like we print 1,000, and then we print the last one and see the result on the last one. Because if the result is good on the last one, the rest is good. Of course. We don't waste material. We don't waste resources. As for the solar industry is like electric cars. There's about debate if it's supposed to last about 25 years. Give or take. I think I think that with solar panel it's economical. Even though the efficiency of a solar panel right now, the highest industry, commercially is about 24%, maybe a little bit more. But I think about 30% is the limit. This is what I read all the time. So it's going to go above 30%.
Right, and it's actually very curious because back in the day, talk about 5, 7 years ago, the top of the top was what 18, 20%, like these.
Even less than that, yeah.
It was probably around that number. The development has been crazy. What are some numbers that you internally at PV Nano have reached out, maybe in terms of efficiency or just these numbers that you honestly did not expect you were gonna find in your products?
Okay, in one of the last experiments that we did, we printed side by side the
Mhm.
same lines and the same lines with the competition.
Yeah.
What we saw in a solar panel without the shading, take out the shading out
Yeah.
because the shading was green, we could save already 25% material and get
Oh.
44% efficiency just on electrical conductivity of the nanoparticle, which this
Uh-huh.
is really amazing. Now, just take into account, now you're going to print very narrow line, you get the efficiency because of less shading from the panel. So they're going to get another 0.5% of efficiency. So this counts a lot for this industry. And this is really a
Wow.
game changer for us.
That's 25% already. That's actually a pretty crazy number. Now,
It's a very nice number, yes.
it is a very nice number. Now, I mean, I understand how this can be reducing the price of the final product, right? Because you use less material. But for anybody who might not be really familiar with it, what is sort of the game plan, or what is the reason why a manufacturer of solar panels would choose to go for this technology? Because it is going to reduce what you said, right? The 0.1% in the prices, because of course the 0.1% in a large scale is a lot. How do you balance these? Keeping it lower material versus keeping it also cost effective.
Okay, so when you go to a customer, uh, customer will not change technology, specifically materials,
Mm-hmm.
because if it need to last 25 years, there is a risk embedded in there.
Right.
So there's a cost of change, and the customer see the saving and
Mm.
make its own ROI. I would say that rule of thumb, if it's like 3 years, it's a go, big go. 5 years, okay, we'll see. Above 5 years, it won't go for change because
Okay.
it's so our saving covered the equipment very, very fast. And this is where we are today. We see that we can save about half of the raw material being used today, which is a lot of money.
Mm-hmm.
A kilogram of paste for heterojunction costs about more than $1,000.
A
And
single
if
kilogram.
1 kilogram would cost more than $1,000 for
Wow.
heterojunction.
That's
Yes,
expensive. That's
it's
expensive.
very expensive. So you can imagine how much saving we introduce into this industry.
Right.
In this industry, you need to refine the technology because you need to get to up to 95, 99.5% yield. This is
Mm-hmm.
a tough challenge.
Right. Especially because I mean I would understand or I would assume that that 0.5% that goes out like to waste, right? It cannot be reused. It cannot be sort of put back in the line. I would understand, right? It's
No, it cannot be. Usually it's going to be either breakage or something went really bad. Because
Mhm.
also these manufacturers, they test the panel for efficiency. Let's say if it's 100% go, they're going to sell it at premium price. If
Yeah.
the efficiency is low because they're going to reduce the price. This is how this market works. So they don't throw everything. But this 0.1%, 0.5% or 1% that they throw, they just simply throw it away.
Right. 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 Yeah. I mean, in the end, it is. I mean, I see the point why you want it to be as effective as possible, but it's already great to know that although you might, if they still take that same kilogram of material, right, with yours, they're gonna be able to print a lot more stuff, which is it's honestly great. So thank you for sharing that. Now, I also wanted to ask you something that's a little more coming back to the R&D side, a little more into the sort of literature as a whole, right? Because I mean, I understand that you are constantly doing a lot of scientific research, which is the bread and butter. I would understand of what you do of your R&D. Do you contribute to the literature? Do you publish papers? Do you go to scientific conversations and stuff, or do you
Uh,
keep it private?
Um, we did it a lot in the past, and we are part of European development programs.
Mm-hmm.
This year, we're working on the new development, and I believe that probably in a year from now, we start publishing because, everything has to be kept secret because we're now writing IP on what we do in the development.
Right, that's
Because,
totally, yeah.
When we ramp up, our strategy is to partner with some other big companies because we are small companies. So
Yeah.
in these industries, nobody will buy from a small company for such a big industry. So you need your backup. So we're not going to go and work with other companies. It's clear to us, and we're already talking with some of them. So we were going to keep it under the hood for a while.
No, and that's totally fine. In fact, I mean, it's totally understandable. You don't want anybody else to sort of steal your process or whatever. That's totally understandable. But then looking also at other type of work that you do for R&D on your website, you have a specific part that says R&D funded projects, right? R&D consortia, Eurostars, Project Digimon, etc. I'm honestly very, very happy. It's very cool to see a company that is doing such great work try to bring their efforts or try to bring the industry or maybe just the scientific world up, right, as a whole. So what led PV Nano to start these efforts, and more importantly, what kind of efforts are you doing today that any student maybe or any academic could take advantage of?
Okay, so PV Nano has a very good name and reputation in participating in such a specifically European project development. Right now, there's a big drive also in Europe because Europe that neglected, for example, solar technology.
Yes, that is true.
Now we want to go back and up in the value chain. It's strategic target for Europe. So we do with them project like different printing technologies, like printing copper and so forth. So these are the major focus of the company. I believe it's a project that would last about 2-3 years. And we work a lot with Fraunhofer in Germany. This is a major hub for us. There's a lot of nice technology there and very nice and talented people over there.
That's very cool. Now, I mean, I know that you already mentioned your career has always been in semiconductors, and in the end, you have a scientific preparation and background, right? From your experience and from your perspective, how different is the landscape of beginning a career in science today versus it was, I don't know, back when you started yourself, I don't know, 10, 20, 30 years ago, I don't know.
I would say that I don't think it's different than before. I mean, for me, it's of course easier because I have the experience. I can talk about the difference between semiconductor and solar. Yeah. Semiconductor is very conservative. Changes take a lot of time. And, everything is so precisely controlled, just amazing. Solar, I think, is simpler technology. They tend to change very fast because if also in semiconductor, you have the competition. So in solar, it's competition on steroids. This is industry. So they're open to changes, to accept changes. And this is the reason that I believe it's going to be much easier to introduce new materials versus semiconductor.
All right. Okay. Thank you very much for sharing that. I was expecting a different answer, to be honest. I thought they were going to say, no, it's a lot easier because it's far broader. It's curious to know how it depends on the industry. It's great to know that. Thank you. Yeah.
Every industry is hard.
Every industry is hard.
You need to find the right door to open. This is how it works,
Yeah, that is true. It's also, I mean, if you're gonna work on research, it's also very long to create a career. It's very slow. That's also true. But thank you very much for sharing that. Now, with all of these projects on your head, I want to sort of poke a little bit your CEO side of this, not so much the science part. But I mean, you have, we just talked about this, right? The funding and sort of all of these R&D sort of side. You have your internal R&D development. You have your manufacturing, not only of the ink or of your nanoparticles, but also of the printers and these devices. You have a big bunch of things under your radar, right, or on your umbrella. How do you, as the CEO, keep everything squared away, especially in financial and procurement and supply chain sites, how do you make sure no part falls behind?
Okay. So I must admit that to run a small company like PV, it's more complicated than a big company because of the size, the team, and you need, as you say, when you have a large company which you run in the past, everything is kind of you have procedures and everything is running according to the rules, and you have a big team.
There's a lot of
here you have to need to take care that company all the time has money in the bank. You need to take care of the different programs. So what I did with PV Nano Cell, the first thing I did, I redo the market analysis to see where the company can make the biggest impact right away. And this is solar. This is why we shifted right now to solar. Two, I built a new management team that is very technology oriented. I can do the marketing and the stuff, but we have, the PhDs and everything. I'm the stupidest guy on the management team. Everybody's like you. So, and I know where I need to keep my eyes on. And, in every company, there's one critical path of development that you need to be aware that is never stays behind. And this is development of space right now for us. And there's a lot, as you probably know, there's a lot of unknowns in R&D, the kind of ups and downs in R&D. So you need to expect what to see and to do all kind of mitigation plan along the way. What happens if this goes wrong and this goes wrong? How you don't lose time.
Right. I mean, it is true that, especially in material science, when you're developing something new, it's very hard to get it right. Yes. So you're saying they didn't have sort of these contingency plans in the past, or they just sort of revamped them?
We had these plans, but with ink we are already okay. When now we move to paste, which is a different field for us, and the particles behave differently in paste, and also the concentration of the metal loading is up from 50% now to about 88%. It's a different ballgame.
Oh.
We have the development plan, and we talk a lot and work less, because when you talk a lot ahead of time, you can maybe predict the future. So you prepare ahead of time just in case this doesn't work. You move right away to this. So you order raw material before time. So when you run these kind of companies, you need to rely on investors' money, which is very expensive. So you cannot lose any dollar.
You cannot lose any dollar. That is for sure. Especially, I believe in the solar industry as well. Losing a single dollar can be the difference between actually getting to market or not. I understand that part. It's crazy. It's crazy. Thank you very much for that. Now, I want to jump now into a more sort of an end part of the interview with a very curious question that I have. Now, I already asked you at the beginning of the interview, where do you see this going in 3 to 5 years, in terms of the materials, in terms of the development you're doing, in terms of the solar power efforts that you're making, right? But now, as a whole, I'm very curious to ask, where do you believe that the printed circuits industry is going with 3D printing, with nanotechnology, with also what you shared up with which is these new pastes and these new materials being developed all the time, not only by PV Nano, but in general across the world? Where do you see it going for the end market?
So with the electronic market, I mentioned before that I'm exposed to development that is being done in Japan, in Europe, and the US. I can tell you countries like, of course, Japan, France, Germany, UK, and also US, a lot out of Texas, we see development. So I see the effort. I think it's the next revolution. It's just taking more time. And everything with the printed electronics, you need to coordinate more partners to get it right. It's not only us. When I come to the solar industry, it's already running. So we do the metallization line. It's a standalone program. I'm not dependent on anybody else. With, let's say, PC board or electronics, we're dependent on other partners. So it takes time, and it must be economical, because also these devices must be cost effective.
Yes.
Now, what I think the industry will need, it will need more companies like us because if you want to use inkjet, you need to make it economical. And if you don't run like 50% metal loading, you're not economical. It costs too much money because of the cycle time of manufacturing. So I believe it will happen. My opinion, it will happen in the 5 to 10 years, not tomorrow. It takes time because
that's for sure.
I see the development, and I think it's the next revolution for the world, bigger than solar even.
Bigger than solar. That's amazing. And when do you believe we're gonna start seeing the copper nanoparticles specifically already in the mainstream? When they're gonna be more effective?
In the solar industry, the industry wants it tomorrow. Yes, but it takes time because of process issues.
Yeah.
It's very complicated. In our area of heterojunction, it's less complicated, but we need to get the sintering temperature lower. This is what we're working on. So it's more straightforward. And this is a big change. We're enabling this heterojunction technology to grow. I mean, as simple as that.
Yes, of course.
You know, in the other section of solar, they're trying to do a copper line coated with silver, but it's complicated and they have extra manufacturing effort.
Yes.
Our effort is very clean, and I believe that it will help the heterojunction really to grow. We're kind of enablers of this industry.
Now that you mentioned the part of manufacturing, I'm very curious. How difficult is it to translate a process from a lab-made sort of procedure, right? Because you're doing R&D, into a high-scale manufacturing process. How difficult is it?
It's an excellent question, and I tell you why. I've done it before. What we do, we plan now a system that is not intended to work. It is intended not to fail.
Okay.
We do FMEA. It's a failure mode analysis. We break the production line into sub-elements and we analyze each one of them. Then we build now a prototype line that is at least 3 times bigger than us. And if it works perfectly, it means it's going to work. And it's not going to fail. And this is the secret behind ramping up. Because to make it work, it's kind of, I won't say it's easy, but it's not as hard as to make it not fail.
Right. It's harder to make it not fail. That's a quote of the interview. I'm telling you already.
In my previous career, I copied from Israel manufacturing facility into Suzhou in China. So I know exactly what it is. I moved manufacturing processes from the US to China. So if you know how to work smart, it's not very difficult.
Wow, that's really, I did not expect that answer at all. But it's great. That's the reason why I like these interviews. I get answers that are very, very different to what I would say intuition is sort of telling you. I would have assumed it's very hard to translate or something, but it's very cool. Thank you for that answer. Now, we're already getting, as I mentioned, into the last part of the interview, so I only have 2 more questions. Okay.
Yes.
The first one is, talking again about the technology they're building as a whole, right? Where do you think that PV Nano Cell is gonna stand during these following 5 to 10 years of the industry development? Where do you believe PV Nano is gonna be? What part are you gonna take in it?
Okay, so it's another good question. I mean, this is a strategic decision for us. We decided that we're gonna do 2 things. One, we're gonna expand our manufacturing in Israel and outside of Israel.
Okay.
2, license our technology to some other big partner, because you need all of the second source in this industry. So this is the direction we're going to take, because also we know that customers, the big one of the world, will not buy from a small company in Israel. You need to have a redundancy in this industry. And
that is true. A name, so to speak.
Right now, we have the process almost ready. We are focusing on stabilizing the process, about the defining and sharpening the electrical advantage, which is translated into a financial model.
Right.
So it's all about, at the end of the day, we're already to the IP, intellectual property for PACE. For ink, we have everything covered. And then we have your question, how to ramp up production. These are the 5 pillars that we're dealing with right now.
I mean, honestly, it is amazing to see a science company, because in the end, that's what you are. You're an R&D company mainly. It's very
Yeah.
cool to see it so well, so firmly standing in the industry. It's honestly really cool. So thank you very much for sharing that. And the last question that I wanted to ask you, it's not much of a question, but advice, right? I want to ask for your advice because you have a very specific type of career behind you. Okay, not only as a CEO for multiple companies or an executive for multiple companies, but also as a scientist. Uh, a career in science is very difficult. So what advice do you have for any aspiring people out there who might want to start their own path, maybe as an entrepreneur, maybe they want to start leading companies as a CEO, or maybe as a scientist that maybe they want to jump into the material science or just generally in the science as a whole. What advice do you have for any of these aspiring people?
Uh, okay, so it's a tough question, but I'll try to answer it. I think that as a CEO, you need to understand, first of all, about yourself, your strengths. If it's a seed company, I wouldn't be able to manage PV Nano Cell because it's going to be only about pure science. This is not my strength.
Okay.
I'm technological enough to know how to ask the right questions, but not to lead the development. So
Right.
I know how to pick the guys, the PhDs. I know how to look at programs. So the most important thing at the end of the day is to understand the market picture, to understand the technology and where the technology is going, and whether you can affect the direction of the industry, which is not easy because you're a small company.
Mm-hmm.
And I would say that once you understand it, you feel it inside, that you have a true understanding. Because in the beginning of this process, you ask a lot of questions yourself.
Right.
There's a point in time that you feel that you understand the questions that you're asking. And all of a sudden, everything becomes clear to you about the company. Now, the last thing that I would say about a company, if you know how to visualize the company, not through Excel, in your head, all the wheels that are moving there, the market, the technology, the competition, you know it. You feel good about it. You feel it inside. And this is in my opinion, the secret for a good CEO, besides saying you need to be aggressive, you need to do this, you need to do that. You need to see how this whole thing's working together. If you don't understand it, it's going to be very difficult to succeed.
Wow, that's actually a very cool advice. Now, I want to do a follow-up question. I normally don't do this, but I want to do a follow-up question. You mentioned that you got an eye for picking PhDs, right? So, what do you look for in a PhD? I'm asking this so any aspiring scientist out there might already know. Maybe if they wanted to land in a company like PV Nano, what kind of path do they have to follow? What do you look for in a PhD to
Uh,
select it for your team?
First, I'm trying to identify the gap that I need to close in the company, whether it's knowledge, whether it's execution.
Mm-hmm.
So where we come from with PV Nano Cell, we know that we lack the knowledge in some area right now in the new product that we do in paste.
Yeah.
But also, I need to keep an eye on execution because execution is very critical to the success because you're
Of
running
course.
against window of opportunity. So what I did, I mean, to be very practical, I called the R&D manager of one of the best companies in the world and asked him to be my advisor. He couldn't do it because I'm his competition.
Okay.
So I asked him, can you recommend me somebody else that can do it? So he gave me a name. And
Okay.
this name is a top notch, probably around the top 5 in the world. So he's kind of part of my team. He's my advisor. And with him, I pick other PhDs, I mean, to complement it. So execution is important. I believe that people with the right mindset and attitude can learn very fast.
That is
But
true.
when you bring people with knowledge, but with the wrong attitude, you're doomed.
All right. Well, we already have an answer. Thank you very much for that. It's honestly great to see these advice coming from a person that has already lived both of those worlds, right? It's amazing. Thank you very much for that. I believe that is the perfect way to give a closure to this interview. It took us a little time, all right? I mean, almost an hour. That is very nice. Thank you very much for sharing with
you.
us your time, Avi. And just a last question: where can we find you? Where can we find PV Nano? What are your social media handles? Your website? It's honestly really cool. I recommend looking at your website.
Yes. We actually were neglected in the last year because we're kind of doing a lot of changes. But
Of
right
course.
now, we're getting back into the LinkedIn and publication and so
Right.
forth. And it's going to be there in the next few months, I believe.
That's nice. That's nice. Thank you very much. Well, in the meantime, just keep an eye on PV Nano Cell across social media, on the website. Honestly, the website is very cool. I'm a nerd myself, and I really like seeing all of these prototypes and all of these.
It will
Uh,
change very soon. It will change very soon. I promise you.
just
The
as
website.
I just hope that we're gonna still be able to see such cool things, videos and stuff.
You will.
That's very cool. Well, thank you very much for that. Thank you very much for the time you shared with us today. Now, everybody out there, remember, you can find a lot of more information, interesting articles, and interviews directly on our website, buildernation.io, and as BuilderNation across all social media. We're going to love to hear from you. Thank you very much for being part of this community. Avi, thank you for joining us in our efforts for this podcast. We were very lucky to have you. Thank you very much.
Thank you very much. Bye-bye.
Goodbye.
Bye.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic 3-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.